international level in NLP and machine learning. So the sir is going to speak about the generative artificial intelligence in large machine language models. So the sir, now you can start the session.
Thank you very much.
Welcome, sir.
I'll be sharing actually my slides there. Okay. As you can see there. Okay, so thank you very much actually again for this presentation. I'm very happy actually to contribute to this webinar. So as I mentioned, earlier on today, I will be trying actually to talk about generative AI in 2023. So we have seen actually, both in terms of different tools, like different products in generative AI. But actually, the success was mainly coming from, large language models. So we will have a look on the history, and what brought us actually to these technologies, but also, I will be focusing on the opportunities and challenges actually around these technologies. So the presentation will be probably around 30 to 40 minutes, and later on we can have a discussion if there is time for that as well. Okay, so first of all, actually, let's go back 37 years ago, when Carl Benz actually applied for his first patent for what he called actually vehicle powered by a gas engine. This is actually, let's say, the first patent for a car, and one actually is, one of the very important inventions actually in the in the automation world there. Okay, it's not only because of the importance of cars in our life, where after nearly 150 years now, from this inventions actually over the years, the ideas of using this new technology, but also because of the debates actually that started after actually this invention. Okay, this debate was called actually the horse versus automobile. So what happens there is that actually around 20 to 30 years after this invention, there was actually a lot of discussions and among the people around the world actually about using actually or changing actually the way of traditional transportation actually, which was based on using horses there. Okay. So as you can see there, this is an ad in a newspaper, asking people or actually to not change their horses. Obviously now we can see it as we can laugh about it, but it was actually very important actually debate in a different part of the world at that time actually. So why I'm bringing this, because in my opinion actually now we are living very similar debate actually. Okay, so it's the 23 or the debate of this century around actually AI, artificial intelligence. Okay, so and there is a lot of discussions actually around us. I know you all are interested in technologies and pursuing actually maybe career in different, actually, development probably of AI models or cybersecurity or different actually ways of, in technologies. But around you, actually, you will probably, if you didn't get it yet, actually, you will get actually all different, perspectives and views around actually the use of this technology and developments actually of this technology. Okay, so again, actually, it led actually to what we call, the hype or anti-hype actually of AI. So it is in one hand, actually, we see a lot of AI researchers and pioneers actually in artificial intelligence, and actually not only the developers there, but also the users of AI and believers in AI. Thinks actually that AI can be, or it is actually what we call the new electricity. So someone like Andrew Ng, is a former chief scientist in Baidu and co-founder of a lot of things, including Coursera. So he's thinking actually, it's AI. It's the the new technology, and you can see similar ideas actually from other researchers like Yann LeCun and a lot of other AI researchers well known in this domain. But on the other side, actually, we recognize as well, as a researchers and possible users that we still have this technology still didn't reach actually the ideal stage yet. Okay, so there is still limited, it's not a blue sky yet. Actually, there's a lot of limit around using this technology, and so that's why there is a lot of work before before making it available to the end users for a lot of use cases, a lot of domains. So again, we see a lot of success in applications like text generation or probably classification, and a lot of domains that now start to be actually kind of solved actually by artificial intelligence. But on the other hand, we need to recognize actually the limit of this technology. Okay, so in order to understand more actually where we are, okay, so let's actually try to understand what is AI in general. Okay, so artificial intelligence, this term actually is coming originally from, or invented, the term itself actually invented by a researcher called John McCarthy. So John McCarthy in the mid actually 15th, with when we start to have actually interest in in using machine learning and using actually automatic training of models there. So he organized actually the first workshop on artificial intelligence, and from there they start actually the term, actually the use of this term artificial intelligence. And by the way, this technology, during the history of AI, or it started actually probably the late 14th or beginning of the 15th from last century, has actually different stages actually. So some period where there was a lot of interest and fund, okay, especially in the 15th. Then there is other period actually where we had like a decline or decrease actually in terms of interest and especially fund, because that's actually the most interesting actually, or important pillar that is actually pushing the technology. If there is no interest and there is no fund, the researcher cannot actually progress. Okay, and John McCarthy actually, he was as I mentioned, the one of the pioneers in AI, but also one of the reasons why we had actually decrease in interest in the mid 18th, where he was, in a report, actually, he was mentioning that artificial intelligence, is artificial intelligence actually might have, a specific limit that cannot, cannot be solved. Okay, so and the limit was on, understanding actually common sense. He was mentioning actually in particular common sense that can be, a human cannot be replaced, or can, in terms of, understanding common sense. Okay, so that's actually was, a reason, a lot of, funders actually, start to have doubts, and maybe not actually, and actually, decrease actually a lot of fund in AI. Okay. So artificial intelligence in general actually, is a collection of, like subdomains. So you might, be familiar, and actually most important part is machine learning. But also it's not only machine learning. We have actually, intelligent robots, automated planning, knowledge representation, reasoning, that actually is important pillar. But also, and we have computer vision and NLP, which is natural language processing. All of these domains, or most of these domains, actually will be using enabling technology. Will be using actually machine learning and deep learning in a data-driven way, but not only. Okay, so there is, different technologies using, like optimization and so on. They might use different ways. Okay, there. So, today here, as our focus will be on, is actually on large language models. So we'll be interested more in the natural language processing technology. Okay, so NLP historically, start as, we're coming actually from the linguistics, field. Okay, so it's the science of studying language, originally. Okay, and so, for a long time actually, so the science of studying language is actually was done only by linguists. Okay, so people understand language, and they will be developing rules and so on, and from these rules I try to probably implement tools later on, when we start actually to start the automation process. Okay, so and slowly actually start to be moving actually from pure linguistics actually to what we called in early stage computational linguistics. Okay, so computational linguistics was originally the science of combining, or actually applying computer science in linguistics. Computer science actually, we mean thereby implementing, actually collaborating with linguistics actually. So linguists they will generate these rules actually, or manually from the data, from their understanding of the language and so on. And the computer scientists actually, or the researchers in computational linguistics, they will be trying to actually to implement these rules in terms of software or code and so on. Okay, and so this is actually until probably late 17th was only this way. Actually, we are implementing actually NLP, so let's say linguistics tools. Okay, and these tools, what they mean there actually is related to application such as machine translation, speech recognition, and even text generation and so on. Okay, and by the way, machine translation is one of the domains that actually driving, more historically and even now still driving actually the, the progress of not only NLP but AI in general. And we will see later on transformers and whatever. Actually, most of the application you can see, they are coming actually from machine translation idea originally, and they are applied even other domains like computer vision and so on. Okay, and the same way, even during the computational linguistics period actually, or stage. So the first huge interest in computational linguistics was coming from a large project actually funded by DARPA, which is the arm in the research arm actually in the US defense there. So they are funding a lot of scientific projects that might have interest in army. Okay, so the project was I think started in the beginning of the 15th 1952 or 53, something like that, and with a huge fund around I think $20 million at that time. 60 or 70 years ago, it is a huge amount of money. Okay, there, and it was the goal is to implement actually a model initially for text, but also they wanted, if possible, actually for speech as well. A model to translate, from Russian to English and English to Russian, and actually mainly they have focus on understanding actually, or translating, and certainly actually, Russian to English texts and probably speeches there. Okay, there was actually a lot of work was done there. Again, actually in collaboration with linguistics, actually, and these work, here, as I mentioned, so they are the implementation of rules. So they are what we call rule-based models. Okay. Unfortunately, it didn't work as they expected actually there, for different reasons, and we understand it now, but again, actually at that time it was very early, stage in the work, so they were actually translating word by word, so they were actually using translation dictionaries. So they implement actually translated dictionaries with linguistics that translator, professional translation. They understand actually Russian and English, and they try, whenever they have a sentence, they try to split in a word, and they translate automatically. So they focus on the fact that there will be instant translation, but they they missed actually the context. They missed the fact that the language, the indigenation of language is different from a culture to another, and a lot of things. So it end up by having an instant system, but doesn't translate well. Actually, it was mainly garbage there. Okay, and they felt and they mentioned that in their report actually, and that's that was actually the first wave of decline actually, or decrease in AI fundings. Okay, later on actually, again, because of machine translation and speech recognition, we start to introduce in the 18th, especially with the IBM models, the idea of using data, and statistics actually, try to understand actually, sending the rules that the linguists actually they were giving us, but trying to extract them automatically from the data, in statistical way. Okay, and that's what actually lead this or drive actually the progress that we are living now. it was a slow progress, honestly, because this technology started from the early 18th, and we start to see actually the fruit, actually result of this technology only the last 10 years, I can say, actually. So where we have really good quality of translation, good quality of classification, good quality of text generation, and so on. Okay, so that's actually in general what happened actually in natural language processing. So everything actually is based and is around understanding the language, actually. Okay, so NLP in general, what we live now is the goal of it is try to understand actually the communication, facilitate communication between people, but also understand how we can process actually human language there. So the first step in this direction is to understand what is actually a language itself. Okay, so so in defining actually a language, we have actually two ways, okay, or two directions there. So the deterministic direction, which is actually driven by linguistics actually in general, which is, and linguistics in general, okay, which is defining a language as a set of all sentences that we can say. Let's say, I don't know, English, okay? So English language is the set or the combination of all sentences that we possibly can say, using English words, okay? So there. So obviously this is actually very theoretical, definition, because in practice we cannot, we cannot, know all these sentences. Actually, it's limited. This set is, nearly illimited. Okay, while the probabilistic definition, which is, what we call the statistical, or the data-driven, way, actually is defining a language as the probabilistic distribution of all possible sentences. Okay, so what I mean there. So instead of actually trying to get generate actually all the possible sentences and put them in a set and say, actually, this is English language, I would be going actually to the words there and say, if a sentence is belongs to the language, so it will have a high probability. So we'll have actually a good probability there. Okay, so instead of generating the sentence or all the sentence, actually we will just ranking or or scoring actually any sentence we have, and validate this belongs actually to the language or not. What does it mean, or how in practice we do that actually is by splitting actually the sentence into a number of words, but also actually what we call in practice tokens. Okay, the tokens could be a word or part of word, or as well actually combination of possible words there as well. But let's say here just for to facilitate the concept is actually we split it to a number of words actually there, which is the unit, and try to calculate the probability. And the idea actually is coming from it's not actually new. It's coming from you know, a long history in linguistics, and again from machine translation. Okay, so you see here in this picture, you know, it's the picture of the Rosetta Stone, which is you know, so they have different names in different countries, but you know, the most common name is the Rosetta Stone, which is you know, it is for, you know, it is now currently actually in the British Museum, but it's taken actually from you know, ancient Egypt. Okay, so it's, you know, this stone was representing actually a way during, you know, the pharaonic period to you know, to present actually a pharaonic decree in 3 languages. So you know, during, you know, the period of, you know, the pharaonic period, actually 3,000 years or 4,000 years ago, you know, the society was actually, you know, you know, like civilized society developed and has actually you know, a very good mix between different ethnicity. Okay, so include, you know, the main ethnic actually parts actually was actually the Greek plus Greek and the you know, Egyptians, and you know, different actually you know, other ethnicity like the Amazigh as well. Okay, and they were living together. Obviously, they are speaking different languages, so they have actually every time actually to you know, wherever there is new decree or rules, you know, they need actually to show it actually in different in 3 languages. Okay. So this stone actually very important for the in, you know, in Egyptology, or which is the you know, the science of ancient Egypt, because actually it was the way to you know, or you know, the actually the only, you know, tool, or the way actually to decode actually ancient Egypt you know, language. So if you see here, you know, I don't know if it's clear or not. So the language actually, you know, this is actually ancient Egypt language. Okay, so the you know, the hieroglyphic. Okay, so if you see here, actually the words or the characters, they are actually, you know, they are it's actually not, you know, standard characters like we have seen now. Actually, so they are mainly similar to emojis now or something like that, which was what was very difficult actually to you know, modern scientists actually, or historians actually, to decode, to understand actually this language. And based on this you know, this decree actually, which is translated in 3 languages, so we know you know, the Greek, for example, is a language that's still living now in Greece, but also in many other you know, countries. So we, you know, because we understand, we can read this. Okay, so we start to align word by word actually, and you know, split sentence by sentence there, and by these alignments actually we you end up decoding actually, you know, all you know, the hieroglyphic you know, language, which is very important. And from the same idea actually there, so we tried actually to bring it actually to statistics or to probabilistic models. So if we can split word by word and try to automatically actually generate actually these sentences, actually, why not apply it actually, generate actually, yeah, the sentence in this language, why not apply, you know, this in trying to scoring actually the sentence, you know, in that language. Okay, so that's actually as I mentioned, it led us actually to the what we call actually language model technology. Okay, so language modeling is the way of, you know, giving actually, you know, score, which is actually probability to a sentence. How we do that actually? So by you know, preparing what we call a corpus, or you know, the or corpora actually, which is collection of corpus. But let's say, you know, you want actually to have a language model for English. So you'll get actually as much as you can, of well-written English text, okay, and try to run actually a model that can extract actually all possible words and their context there. Okay, so what happens actually, we'll try to extract all unique words. Then after that, their occurrences, okay, where we can use these words actually, and we every time we'll give probability for for these words. How we give the probabilities is actually by getting this word actually. For example, let's say I have train. Okay, so and I have, for example, in my corpus, we have like maybe 10 sentences there. Okay, so we have the train can be used, the training model, train machine learning system, or train actually, training in the gym, okay, or training in a, for a football match or something like that. Okay, so there is the different context. Let's say, our context actually in this language model will be mainly for scientific use. Okay, so you'll have it within the 10 languages, 3 times training related to sport, and 7 times training language, training model, train language model, training language model. So we'll be having actually probability that when we have a train, 70% of the times will be actually language model will arrive after it, or language, and probably after the train language will be model coming after it. So we'll be saving actually this information. This is actually a rule. Okay, we save this information there, and we try to use it later on actually to scoring actually the model. Okay, so how we can use this information, which is actually all these statistics there. So in scoring actually any new sentence. Okay, so so that's actually the idea here. So if, for example, here I have the word like actually, so in my corpus saying actually there is high probability to have cats actually after like. Okay, and so whenever I want to predict what I have actually after I like will be cats, and that's actually will be leading us to generating actually sentences, because we learn actually from this corpus, or from this collection of texts, what is happening there. Okay, so what are the possible predictions, or the words that might have better actually better probability, or a higher probability to be in that context. Okay, and that's actually how we start to understand actually the context, and they use it actually in different use cases or treatment applications, including, for example, the classification. So when we want actually to classify let's say texts, actually news, for example, articles into sports articles, and political articles, and finance, for example, articles, what we do actually, we try to get all these words actually, and try to unique words, and try to see actually to extract actually the probabilities or of having these words for, let's say, a bank. Okay, a bank, you will have more probability to be actually within the context of finance, while a goal will be within context of sports. Okay, so learning this information actually will lead us actually to generating these models for classification. And the early models, they were using actually what we call the bag of words, which is just trying to look into, for example, one domain like finance, and try to extract all the possible words related to this domain. Okay, And by the time actually we start, this bag of words actually was a technology that stays actually for a long time, actually around 30 years or more. Actually, there it was, for a long time the state of the art, and the main technology that start to improve it, there. But it was actually the main idea until actually 2013. Where actually, researcher at the time actually, I think doing actually his PhD and an internship actually in Google, Thomas Mikolov. Okay, Thomas Mikolov actually come up during his PhD with the new idea of actually inputting actually this text, actually trying to use this text. Okay, he said actually instead of using this, let's say a bag of words, just collecting these words together actually without. So I know actually we did this bag of words in classification context. We might know actually this word, the domain of the word, but also we can we don't have actually a clear idea about the context, the actual context of these words. Okay, so like for example, the word bank. Okay, so it can be actually used in finance, and it is widely used in finance, but also it can mean actually in other contexts, something actually related to river, something related to whatever. Okay, so even in political, articles, you can have West Bank, the whatever. Okay, so it might have actually create a confusion, and that was actually the limit of this technology. Okay, so Mikolov start to think actually about another way where we can actually understand better actually the context of the word. So instead of extracting the statistics there blindly, let's say, okay, so we try to extract actually for each word its context. Okay, so by what we call a representation. Okay, so we represent actually a word in a vector space. Okay, so of words that can be around each context. So now, so we don't, compared to the previous method, so we don't say actually this word will be exist like 0 or 1 existing actually in finance or not, but we can have actually a dense actually vector, smaller vector and dense, that can contain actually the possible words that can be around that specific target. This actually was a revolution actually in NLP and in actually representation of text, because actually it opens the door actually to or kind of the first revolution in the last 10 years, because we have actually, let's say, in my opinion, two main revolutions actually: the word-to-vec, this actually the Mikolov method, and actually later on we see the transformers. Okay, so the word-to-vec actually was actually the first phase in this revolution. By the way, it was actually exactly 10 years ago invented there, like in September 2013 there, and this is actually the paper if you want to have a look there. So so this is actually the technology, I say, we open the door for better representation of text and better understanding of the context there. Okay, later on we start actually to progress in this direction of how to represent actually or better represent actually and improve this representation of text, because we see actually the effect there. So we are trying to start to understand actually the context. We start to understand actually that if we know actually for each target actually how we can represent actually the words, so it would be better translating, better generating text, and so on. Okay, so later on actually we moved actually to what we call actually the sequence to sequence models. So which is again a neural network architecture used actually, you know, for tasks like machine translation. There, it's another way actually to just, you know, more, you know, getting better the context and improve actually the process there. So in translation, for example, traditionally before sequence to sequence model, these models, we used actually to use what we call statistical models. So statistical or SMT, statistical machine translation models, are based on based on implementing actually translation models from text and its translation. So every text we split actually to what we call phrases, or even words. Actually, we extract actually for every phrase which is actually a collection of words. Okay, it's translation in a translation model. And this translation model will be generating us actually all possible translation for every sentence. Let's say we generate, for example, 100 possible translation, there. Okay, so we have the word in German actually, and we want to translate it to English. Okay, so word in German, we have actually, let's say, 4 phrases. We go to the translation model, will be extracted from a corpus, okay, by text corpus, the corpus of German and its translation texts, okay, and try to, for every phrase, we can get its translation from this translation models, okay. So we get this translation of these 4 phrases. From there, actually, blindly we generate actually, let's say 100 possibilities there, okay. Still, we have 100 candidates. What we do there is try to rank actually these candidates using what we call a language model. Okay, so the language model will be used actually separately, to improve, let's say, the fluency, and to say actually this is actually more fluent in the language, okay, than other ones. It could be a garbage because it's actually the order is wrong and so on. Okay, so that's actually the idea, of statistical models, which is, it was living actually for around 20 to 25 years there, until we start actually to think actually, with the success of actually with or the representation and word2vec, we say actually, why not including more context? So instead of giving separately these sentences, actually we give to the model the 2 sentences together, actually the German and the English sentences together in the training side, okay, or training phase actually. So this system will be trying to learn how to predict actually the the first word actually in English. So if you are translating from German to English, after having actually the context of all German words there. Okay, so that's actually the the main idea of this technology, and start to actually to be used in other domains, like mainly actually text generation, especially in dialogue actually there. So we in that dialogue is actually mainly it's sequence to sequence. So we get actually a huge corpus of let's say movie dialogue, or different or discussions from social media, and we run actually a sequence to sequence model to generate to train actually let's say a chatbot. Okay, it was good actually, but especially in domains like chatbots, it was very, very limited, because it's still was reflecting actually the the data that we trained it on, and also these data sets in the context of generating text was very, very limited. Okay, so we start to think actually on improving actually these this technology until 2017 actually, where again in machine so this one actually coming from machine translation. The same thing here actually. This is actually the most important actually paper in my opinion in the last 10 years, okay, which is the the paper introducing transformers. Okay, so the paper actually in transformers actually is coming actually as a progress in sequence models. And in this model we start actually, so the researcher there introduced actually an attention, okay, to specific. So the problem actually with the sequence to sequence models is that, okay, we get the context, but when the context start to be long, okay, so these models lose it, okay, so we lose the context when we have long sequences there, okay. So the solution for that actually, again, coming actually from Google, it was by introducing an attention to specific part of these of these sequences. So we will keep actually the we save actually the context, and it was very, very successful because it started actually to be useful in other applications, especially in conversational agents or conversational models. Okay, and all what you see now in terms of advanced technology in conversation agents and chatbots and so on is coming actually from using this technology, the transformers. Okay, if you have a look actually now on what we call actually the large language model, the Explorer there actually, or the tools there, so you can see like maybe I think all of them, okay, not only the majority, are using actually the same technology. So all actually coming actually from word to presentation actually. So word to vec is the initial way. Then in all these models actually, so they in a way or another actually they are representation, or actually they are using actually transformers, okay, there. So we might heard, I'm sure that you are aware of ChatGPT, but there is a lot of other tools actually. Some of them are open source, and some of them they are still used for commercial use, and say like I say not black boxes, but actually it's so we don't have access into modifying these models. Okay, so and there is a huge competition there between tech companies, but also research institutions in making more models useful for different applications there. So there is models now for telecom, models for biology, language models now for for different so let's say ChatGPT, it's based on information get from internet, so it's including different languages, but it's actually better in English, okay, because in internet we have more English text than anything else, okay. So it's still limited in many what we call low resourced languages. So that's why there is specific focus on for implementing these tools for specific languages there. So so this is actually the enabling technology, and an idea about the enabling technology there. There's a lot of details around that. Happy to discuss it with you, but just to like a general introduction of the enabling technology. So so that's brought us actually to the ChatGPT year, which is 2023 is like kind of and actually late 2022, and this 23 was actually in my opinion, the ChatGPT year, or large language model years, what started actually to be more widely used in different domains. Okay, so in ChatGPT, what we have there actually is or what do we mean actually by GPT itself? Okay, so the G is for generative pre-trained transformer. So again, so that's actually the technology itself. Okay, so it's for generating text. Okay, and this model are already pre-trained. Okay, so we train this model on a huge amount of text. Okay, so generative is here. It means that the model is capable of generating continuous generating text. Okay, pre-trained model means actually it's trained actually offline on a very large corpus of generated text there. Okay, so we had different versions of ChatGPT, and every time actually we increase actually the amount of text, but also the number of parameters. Okay, So in GPT-2, which was actually one of the models that actually to be used actually in the conversational model, agents there. So we had actually 1.5 billion parameters. But compared to what it was used in GPT 3.5, this is the free version of ChatGPT. So we have 175 billion parameters. Okay, in GPT-4 and the new one 5 and so on. So we have actually a larger, probably something like around trillion, trillions and more. Okay, so there is so in Llama, for example, there is now the standards as to have over 540 billions parameters, which is something really, really huge. Okay, which is actually lead to thinking, Jeffrey, Hinton is one of the pioneers actually in deep learning. He was thinking actually that at the end, with this success of GPT models or large language models, maybe the whole information or actually or the answer of everything in the universe is just a model of a few trillions actually parameters, which is again will open again another debate around these around these models there. Okay, so so that's actually the debate actually mainly around the limit of these models, but also possibility the possible not danger but actually problems that these models might generate. Okay, so again if we take actually the ChatGPT actually model, the success actually is coming mainly when we start actually to include human feedback. Okay, and earlier even with transformers, so we generated a lot of good text, but they have problems in context, in understanding actually common sense. Okay, if you use, for example, early GPT or GPT-2 there. So this with a huge amount of parameters, and you ask GPT-2 how I can put an elephant in a fridge. I say, the model probably will tell you open the fridge, put the elephant, and the close the fridge, or how I can eat the moon. Say, take the moon, put it in a sandwich, and and eat it. Okay, which is the same actually, reason why John McCarthy, as I mentioned earlier on, mentioned actually the limit of these models. Okay, while now with the human feedback actually, or what we call reinforcement learning actually technology, we start actually to include the human in the loop and try to whenever we have a wrong answer like this, we correct it. Actually, we instruct the model to improve it actually. Okay, so and that's what led actually to the success of ChatGPT based on the compared to the other technologies there. Okay, so actually this idea started actually from a model called Instruct GPT, which is just coming after GPT-2 in late 21 and beginning of 22, and that led actually later on actually to paved the way actually to the success of GPT 3.5 last year. Okay, so the idea in general is that you have actually a model, and there is a human in the loop to improve actually there. So the model actually be learning from these correct answers actually, and you will be avoiding actually this mistake next time. Okay, or not only that mistake, but similar mistakes. Okay, or similar failure next time. And that's why ChatGPT was very, very different actually from other technologies. Okay, that's actually brought great success to these companies, which is originally was its goal actually to democratize actually the AI, but I think now, it's not actually going to that exact direction, in my opinion. But anyway, so still they are still collaborating with some research, institution as well. Okay. Yeah, so that's actually the main idea of GPT. So here, as I see, so you have always the human in the loop. In ChatGPT itself, actually in November 2022, so they used actually the same idea, and they added actually a safety layer, okay, with a nice IO. So this is actually in a nice interface. Also, it's important, So the technology is very important, there in terms of generating the quality, but also one, in my opinion, another, part of the success of this model is the interface itself. So whenever you are thinking about a product, hopefully, we can see many of you actually having your own projects one day. So don't think only about the technology itself, but think about how the users actually facilitate actually to the normal users actually that you are targeting. Okay, so the interface actually, in my opinion, was one important part of the success of ChatGPT models there. Okay, so now actually we have seen these technologies, see how how it was actually developed, and progressed actually from early rule-based to pure learning, still with human in the loop there, and we wanted to see the opportunities there. Okay, so here. Yeah, I mean, actually, we are within actually an education context, so that's why I choose actually here, opportunities within actually the education actually. Okay, so and so within that context actually, so we have the ChatGPT report by by UNESCO, which is actually published, I think, in March this year. I think maybe 4 or 5 months ago, and they were actually. So there is a link, for this, or you can just Google it, ChatGPT guidelines on UNESCO. Okay. So within actually this report, they were mentioning, trying to introduce the technology and so on. By the way, actually, this picture also it was generated automatically by DALL-E 2 model, which is another generative model, but generating images instead of text there. Okay, so and is the same, using similar technology. Okay. Sorry.
Yeah. So.
Do I still have time? Sorry. Yeah.
No, sir. Because of a shortage of time, so we would like to end this session now.
Yeah. No problem. Yeah.
So thank you so much, sir.
No problem. That's actually the last slide there. Okay.
Okay. All right. So you can continue.
No, that's fine. So actually, just actually have like this this slide around opportunities, and just the only thing that I just want to add there is around actually the carbon footprint of AI. So this is actually the challenges there that we are facing. These models are, if you see, so they are giving, as a lot of, opportunities in use cases, but also they are, consuming a huge amount of, resources there, okay, computer resources. So need to make sure that whenever you build, these kind of models, actually, you don't actually overuse, the computer resources, because it has a big impact, in the environment, and in the climate change that we see is results now. That's all, from my side, and thank you very much, actually, and apologize, actually didn't have, didn't see the time there. Thank you very much. I don't know if we have actually time for questions, or I don't know, maybe. Maybe the moderator. So do we have the time for questions? Yeah.
Yes, sir. Yes, sir. We have the time of the questions. Now, students, loud now. So thank you so much, sir, for the very informative sessions. So students, like sir have talked about the artificial intelligence, the large language models, even the latest technologies like chatbots, transformers, and chat GPTs. So if you have any questions, you can ask write your query in the chat box. So any question from the students?
There is, I think, a student raising hand there, Samir Sharma.
Yes, Samir, do you have any queries, Samir?
Feel free to ask in general, not even related to this topic. If you want to, to have any, if you have any query related to whatever, artificial intelligence in general, or the technology in general, I think you are in the early stage there in the university. If you might, have idea where to go or something, actually, or any recommendation, more than happy, actually, to help us.
Definitely, sir. A few students have raised their hand. Students, you can write your query in the chat box. So thank you so much, sir, for your time. You have given us very informative session to our students. They have learned about the latest technologies today. Thank you so much.
No problem. Thank you very much for the invitation again.
Most welcome, sir.
Thank you. Thank you. Bye.
So students, so now our next speaker have joined us new session. Ms. Vanshika Saraswat has joined. So let me briefly introduce our next speaker. So ma'am, she is an MBA graduate in human resource and aviation. The ma'am has worked with the IndusLand Bank as the HR journalist. She has also worked with the Byju's under the recruitment, and now currently she is a part of Wipro campus team. So ma'am's specialization is attracting and hiring students, and she recently graduates recent graduates for the organizations. So ma'am has over a large experience and looking forward to work with the young talent in the market. So next, now over to you, Vanshika ma'am. You can continue your session.
So thank you so much. It's great to have this interaction session with our Gen Z people. So this session is specifically for all the fresh graduates, I think the 2024 pass outs. So it's great to have you all here on this platform today. And thank you, WCTM, for giving me this opportunity to speak in front of your young budding candidates.
It's a
so
pleasure.
We will, yes.
Thank you.
So we shall proceed towards our topic for the day. So we will be discussing about what the future candidates, what all you expect from the industry. So I think all of you are studying, you all are in the final year of your graduation, or you must be entering into your first year of your graduation. So this is your orientation sessions for with our industry experts. So before we move ahead, I just want to give a brief introduction of mine. Myself, Vanshika Saraswat. I work with Wipro. under the campus recruitment charter. And I specialize in attracting young talent from the non-engineering sector, which is specifically the BSc, BCA, and the diploma students. I'm sure there would be multiple category of students present on this platform today, right? So I will not speak much about, I'll not come and speak, give you lectures and all. It will be a very short session. I will just speak what I want to communicate as a matter of my topic of discussion, which is trending in the market for now. And then I can take up your questions. So just wanted to give you a glimpse about what you expect from the market, from the industry. All of you are studying. You have no idea about an organization. What are the trends we follow? How do we work in an organization? And you have a couple of things to expect from all of us when you join the organization. So stay tuned with me and let's start with our topic. So basically, the workplace, you all are aware, we all work in a diverse place, right? And this Gen Z term is something which was born into the era of late 1990s and early 2010. So basically, all the candidates, all the students, any person who is born between the age of 1995 till 2010 will be under the category of Generation Z, which we commonly and very trendy, we call it as a Gen Z professional, right? So, born into this digital and connected world, all of you are aware that we wake up. As soon as we wake up, we have been working on the mobile phones. So, we are spending half of our waking hours on the screen. Our screen time has increased all of a sudden over these years just by the internet culture and the social feeds, right? So I just wanted to bring you to the notice. Recently, there have been a couple of surveys which are conducted. So 1 out of 3, the Gen Z people, they are under pressure, under stress at work, and 99% of the candidates of the professionals are under stress because they're because of lack of work life balance, and they burn out in their jobs, right? Some believe that there is no job satisfaction. So all these are certain aspects that we discuss. So only things that we look seriously are the efforts. We are working in an organization where we are hiring people, we want to retain the top talents. All of you are aware about how a company works. All of you must be curious to know the trends in an organization. But this is something I can give you a clear picture. What changes have been emerged over a period of time? What are the phases which Gen Z has gone through? So I have already given you an introduction. People born between mid 90s and early 2000s are the Gen Z. So they are put up in the category of millennials. Why? Because there's a very skinny layer of difference into that. We are much more tech oriented. Now, what do all the Gen Z people, all of you, expect from their employers? Once you join the organization, Gen Z people, they believe in the freedom of thoughts, right? So all of you, in fact, me working with our managers, we have a unique point of view regarding whatever we are coming across, right? Employers usually make the mistakes. What we do, we are working in an organization. We neglect the mistakes of our young ones because we think they are not aware. We are the experienced ones. We know how to handle better, but it's not what we expect. What Gen Z expect from an organization is the freedom of thoughts, right? So these individuals, we constantly believe combining with the latest technology. I'm sure you would be able to resonate your life with what I am trying to explain. So in an organization, you will get freedom of thoughts because this is a character trait that all of the Gen Z people, they have, they have always wanted to. Then the next thing is that we as Gen Z part, we believe in the flexibility at work. So during this COVID times, earlier we were working from offices regularly. There was no question on that point. But now, since everybody has moved to the remote style of working, we want to work from home, we work that flexibility of work. So we do value our personal lives as well as our professional lives. We want to have that balance in a work from home and a work from office day. We want transparency in the working culture. So basically, the character trait of these Gen Z professionals is very intuitive. Intuitive in the way we do not refrain from standing up against the situations. Whatever we have thought, we want to get it done. We crave for transparency everywhere so that we can make right decisions at right point of time. And having a transparent working culture has nowadays become so crucial, because this can actually lead to a better productivity and it can boost the confidence of employees. So I am sure all of you would want these few parameters, you want these few traits from your organization. What we discussed so far is the flexibility, transparency. We all want that remote working style. We want a freedom of thoughts. Moving next is, we also want an organization which gives us scope of learning and development. So we always want money. Of course, we all look for package. We want a higher package. Apart from package, apart from career growth, we also aim at the scope of learning and development, which means learning is the new key. We always want to grow each day. We want to learn new skills. We want to learn a new module. We want to keep learning because we think learning will keep us motivated and we can be at par with the levels of technology. Next is access to latest technologies. See, technology is changing every day. And if you are stuck with one technology, it won't lead to successes in your future. What we want to be updated with the latest technology, which means in this challenging working environment, we cannot work only with the traditional methods. We cannot work. You have seen that earlier there used to be an auditor who used to write with a pen and paper, who used to manually do all the audit work. Now everything has been replaced. We are working with the chat GPT, with the artificial intelligence, with the automation. I think previously you had one session related to AI. So we all want to be updated with the latest technologies. And this is something we can become Gen Z millennials at workplace. We all want to work with less bureaucracy. Bureaucracy meaning we are not the rule breakers, but we are the rule creators. We want to work in a freedom. We want our own space, which is unmatchable, right? The level of energy the Gen Z candidates, the Gen Z professionals have as of now is unmatchable with the people who belong to the traditional era. So our managers, our seniors must be lacking behind in terms of technology, what you all are standing here today. Uh, Last one I would just like to say in the matter of effect is the support for social causes. So earlier people used to be too much into the CSR thing, too much into society. But now also the Gen Z, the Generation Z people are involved in lot many social activities. We all want to contribute something or the other towards the welfare of society. And all the Gen Z employees, they feel very much motivated to give the best of their performance. But what has happened is, due to COVID, there is a setback in the academic process. Like people all like you, I'm sure you belong to the Gen Z category. And the people who were studying before COVID, they were visiting the colleges regularly. They were going every day to attend the classes. But during COVID, there have been a changes in the academic progress also. We are just making the candidates pass and promoted without actually analyzing their academics, without actually analyzing their other areas, the other gray areas where they're lacking behind. So this is how the productivity has been decreased. But Then again, the question comes up, are the Gen Z people compensated fairly? So, no. What has happened post COVID era is we all are paid less. We all are offered less in terms of our CTC package just because there has been certain market conditions, there has been recession coming up. And this is how we Gen Z employees are only working without being motivated at all. But I just wanted to give you certain updates. So all of you are working, all of you have joined into your career journey. Make sure you utilize, because this generation is known for the internet era, right? We all wake up in the morning using our smartphones. So we are having the n number of options for the technology that we have in place. So you can imagine that the technology we are working, make the best use of the technology in and around you, which can make you motivated. I am sure by completing your 3 years or 4 years of your graduation, you all would be able to crack your placements. You all would be somewhere placed up in terms of your career. So this was just a highlight I wanted to give you. And now I'm open to the questions if you have any, so that we can wrap up my part.
Thank you so much, sir, ma'am, for your valuable words. So student, now if you want to ask any question from the ma'am, you can write it your questions on the chat box. The query session is open to students now.
I think candidates are confused about what Gen Z actually stand for.
Yes, absolutely, ma'am. The questions from students?
Yes, Gen Z, Astitva Gen Z actually means the today's era. And basically, all the candidates who want me to just answer this, how much CGPA matters. So to enroll into any such domain in Wipro, you are required to have passed in your 10th, in your 12th, and you should have at least 60% of your percentile in graduation, right? So anytime if you plan to visit the Wipro campus, I am there in the Greater Noida campus. We can discuss this with your placement officer, and we can have the industrial visit too.
Sure, ma'am. We'll definitely plan and visit to the Wipro, definitely.
Any other questions, candidates? Yes, we all use chat GPT. We all are so much technology driven. We all are tech savvy people. So that is why make the best use of technology around you, so that you all can be the part of organization like Wipro. So product effective marketing. So I am not into the marketing thing. I am basically into HR. I have done my master's into HR and aviation. It's just be confident, and you all can be the part of any personality development classes in your college, and just try to speak up, remove that stage fear. Exactly, chat GPT and this Power BI and artificial intelligence, they have made things very much easy. So I would actually say, Kushi, you should focus, you should make a balance of skills and your degree. See, for degree, at least 60% is mandatory, right? Along with 60% basic, you can learn a couple of skills in your college. And of course, once you join Wipro, we will definitely train you in certain skills before actually giving you what to do.
Right, ma'am.
So those who are still not aware about the organization, search after this session what the organization is all about. And this question is for Shivam Rathor. You can have a Google search. So internship opportunities in Wipro are only to candidates whom we have offered Once you complete your graduation in the 5th semester, we can give you internship opportunities as well.
So any other questions, students?
All right. Thank you so much.
Thank you so much, ma'am, for joining, for giving your time to us and making our students understand the meaning of recruitment or Gen Zs and the latest technologies. Thank you so much. Thank you so much, ma'am.
Thank you.
So, students, this was their last session where Vanshika Saraswat ma'am, she has talked about the campus recruitment, the HR. She was from the HR department. And those students were have query related to the Hatim Afli sir. So we'll definitely going to have these kind of sessions in the coming coming sessions. So don't worry about that. We'll have more sessions in your coming days, right? So now I just hand over this to the Shraddha ma'am. She is the director placement. So you can continue your queries or you can ask any query from ma'am also. So dear students, the session is over now. So we would be having an off tomorrow on the account of Janmashtami. Then we'll be having sessions on 7th. On 7th, we have Miss Archana Sharma. She is Pravasi Bharati Awardee 2023 by Government of India. At 10:30, then at 11:30, we have Shobha Rana ma'am. She is an entrepreneur and an emotional intelligence coach. Then we have address by Vandana Bangaji. She is a emotional intelligence practitioner. And then we have interaction with Surbhi Jaiswal. She is HR in Just Dial. So we'll be having a very good session on 7th as well. For tomorrow, you will be having off on account of Janmashtami. So I wish you all a very happy Janmashtami to you and your family. May Lord Kana bless you with good health, wealth, and prosperity, and all your dreams come true. कृष्ण जिनका नाम गोकुल जिनका धाम, ऐसे श्री कृष्ण भगवान को हम सबका प्रणाम. कृष्ण जन्माष्टमी की सभी को हार्दिक शुभकामनाएं. So guys, now we are going to end our session. Thank you very much for listening all these speakers so patiently. Happy Janmashtami, guys. You can leave now. Thank you. Thank you so much, students. Happy Janmashtami to all.